Welcome to A Lesson with Dr. Powell. Let's take a look at finding the instantaneous rate of change of a function at a point. So that's the slope of the tangent line of a function using the limit of a difference quotient. We're going to use the A strategy, but also then use the H strategy and see the results are the same. So to use the A strategy, first of all, or in both, we actually need to find a point, the point that we're heading toward at x equals 2. So we know we have the x value is 2. What's the y value? The y value, you stick 2 in, and you're going to have a third. Then for the A strategy, you stick in just a point, arbitrary point x equals a, and you plug that into the function. You're going to have 1 over a plus 1. We're going to be looking at the rise over run between these 2 points. So the rise, take the difference of the two y values, like this minus this, and this minus this. You have 1 over a plus 1 minus a third, and that all over a minus 2. And we're taking a limit of this as a approaches 2. Okay, now in computing this limit, notice that we have, denominators inside of the numerator. Maybe that's not quite desirable. It would be nice if we could simplify the numerator in such a way so that our domain problem might cancel out somewhere and we can plug in a is 2 eventually. So let's try to work with the top to see if we can get an a minus 2 lurking somewhere in an equivalent form of this fraction in the numerator so we can cancellation. So what should we multiply top and bottom by? Well, you see these denominators. Why don't we just do 3 times a plus 1? Just kind of put those denominators in there, or the least common multiple of those two denominators, so that when we multiply in, things will cancel nicely. We do that to the top and the bottom, so we can get an equivalent ratio, equivalent fraction here. So as this whole bit distributes to both parts across the subtraction, we're going to get some cancellation. The a plus 1 will cancel that a plus 1 in the first term here, so we'll just end up with a 3 when this multiplies into this part. When this multiplies to this part, the 3's will cancel, we'll be left with an a plus 1, so it'd be minus a plus 1 on the top. And the denominator, we have a minus 2 times 3 times a plus 1. And this is going to be equal to, we're taking a limit as a approaches 2. Notice this is nice on the top because when this simplifies, we're going to get minus a minus 1 and 3 minus 1, that's 2. That's a 2 minus a, which is this exact same thing as a minus 2 with a little negative. You can, on the front, factor it out. You can check it. If you distribute in the negative, you get negative a and positive 2, rearrange. See, let's think. Is that right here? A minus 2. Yeah, hold on. We got a minus 2. And yeah, because that becomes a negative a and a plus 2, and that becomes that, right? Yes. Okay, so the top part right here is negative quantity a minus 2. You have an a minus 2. Notice that this is the whole top. So it's like negative 1 times that. So a minus 2 really, this is the whole top of the fraction. A minus 2 is a factor, and a minus 2 is a factor at the bottom. Back to the top, bottom, divide top and bottom by a minus 2. You get cancellation. On the top, you're left with negative 1. So in the limit, you're going to have a limit as a approaches 2, negative 1 all over 3 times a plus 1. Notice we eliminated the domain problem, so now we can plug in 2. Plugging in 2 for a, we end up getting negative 1 over 3 times 3, so negative 1 over 9. And negative 1 over 9 would be the result that we're after. That's the instantaneous rate of change at 2, namely the slope of the tangent line of this function at x equals 2. Now, that was the A strategy. Let's take a look at the H strategy. So for this one, H is representing the run. Again, we're going to be looking at that point. 2 and a third. But now we're going to be saying 2 plus the run is the x point of the other guy. And we stick that into the function to get the y value at that point. So we have 1 over throwing 2 plus h in for x. So 2 plus h plus 1. Okay, so then we take the rise over run with these points. So this minus this, and we can rewrite this is 1 over h plus 3, this part. So 1 over h plus 3 is this guy minus that to give you a rise all over your run. Now again, remember, you'll notice that the run is just going to be h. This minus that was h, and that's how we designed it anyhow. So you always have an h on the bottom. And what are we taking a limit of? So here we wanted a to be going to 2, the two x values to go together. The 2 points move together. Well, as the 2 points move together here, the run itself is going to 0. So we're going to have h going to 0 in this case. Now we approach this in a very similar way to the last one, and we'll multiply top and bottom by the same thing. Here we'll do, I'll write it this way, 3 times h plus 3, 3, h plus 3, and I guess I'll just use parentheses. Okay, so when this whole bit comes in and multiplies into both sides, we're going to get something very similar. H plus 3's will cancel here. We'll be left with the 3 on the top for that first term. Here as it comes in, the 3's will cancel. We'll be left with a quantity h plus 3 subtracted, and that'll be all over h times 3 times h plus 3. And we're taking a limit as h approaches 0. Notice that on the top, we're going to get 3. This negative will distribute, so 3 minus 3, 3's will cancel. We'll be left with just negative, so the whole top will just simply be negative h. Now, notice h itself is a factor of the top. We could have just thought of this as negative 1 times h. So h is a factor of the top, the bottom, so therefore we can cancel when we divide out by h. Division is like eliminating factors. So we can do that if we divide top and bottom by the same thing, by h namely. So we're left with negative 1 on the top. We're taking it, so this is equal limit as h approaches 0 of negative 1 all over 3h plus 3. And now 0 is not a domain issue. We can throw it in. And you notice we end up getting negative 1 over 9 as well. So that was the A strategy and the H strategy of finding the instantaneous rate of change of this function at a particular x value. And thanks for watching.